Hello, everyone. Today, I am going to talk about the January 2026 Chile wildfires in the Bilbo and Nublit regions. My main point is that these fires were not just a normal wildfire disaster, they show how extreme weather, climate change, air pollution, and soil damage can all connect together in just one event. First, I'll explain what happened in Chile. Then I'll talk about why the fires became so severe, especially the role of extreme weather and climate change. After that, I'll explain how this event connects to air pollution, and then I'll talk about the soil impacts after wildfire. At the end, I'll bring everything together and explain why this event matters as a much bigger environmental case study. So, first, I want to explain what happened. According to Reuters reporter Alexander Villegas on January 19th, 2026, Chilean President Gabriel Boric declared a state of catastrophe in the regions of Nublet and Biobío after the fires killed at least 18 people and forced around 20,000 people to evacuate. Reuters also reported 24 active fires, nearly 8,500 hectares burned, and at least 250 homes destroyed. The situation also got worse very quickly. According to NASA Observatory on January 21st, 2026, by January 20th, the fire has already burned more than 30,000 hectares. NASA also cited UN reporting saying that the fires had caused 50,000 evacuations and destroyed more than 300 homes. So even within just few days and few hours, the scale of the disasters increased a lot. That shows how fast wildfire events can escalate when the conditions are right. So the next question is, why were these fires so severe? Well, for that, I used a 2024 study by Carrasco, Escaf, and colleagues. This study looked at extreme fire seasons in south central Chile and found that especially bad fire days happen under a combination of high temperature, low humidity, and strong winds. The authors also concluded that climate change has increased the probability and intensity of extremely warm temperatures in south central Chile. I think this is one of the most important scientific points in this presentation. Climate change may not directly start every wildfire, but it can make the background conditions hotter and drier, which makes fire easier to spread and harder to control. And that matches this event too, because Reuters and NASA both describes the January 2026 fires as happening under hot, dry, and windy conditions. So, my second main concept is air and air pollution. This event was not just a fire on land, it was also an air pollution event. According to NASA's Earth Observatory, satellite imagery from January 18th showed smoke billowing from multiple fires in south central Chile. Also, the Copernicus Atmosphere Monitoring Service reported that it was tracking the smoke emissions from wildfires across the southern hemisphere, including Chile, and it highlighted smoke transport across the entire southern hemisphere. I think this part is really important because it shows that the impact of the fire did not stay only in the places that burned. The smoke spread much farther, which means the fire affected the atmosphere on a much larger regional scale. I also wanted to talk about what happens after the fire. For that, I used a 2005 article by Paredes, Delgado, and colleagues. This source focuses on volcanic soils in central southern Chile, including the Biobío region, and it studies what extreme wildfire does to soil properties. The article explains that temperature in a 2023 wildfire reached up to 600 degrees Celsius, which caused major physical and chemical changes in the soil. What I think is most useful here is that the authors say the dataset can help identify areas with higher risk of ground instability after wildfire. That matters because wildfire damages is not just about flames and smoke. It can also leave behind long-term land problems, including soil instability and erosion risks. So, Overall, I think all of these sources tell one connected story. Reuters give human emergency and government response. NASA shows the scale of the fire and smoke using satellite evidence. Carrasco Escaf and colleagues explains why extreme heat, dryness, and wind made the fire more dangerous, and they showed that climate change is making these kinds of warm conditions more likely. Copernicus shows that the smoke also mattered at a atmospheric level, not just the local level. And Paredes Delgado and colleagues shows that even after the fire ends, the environmental damage can still continue in the soil. So my main takeaway is that the January 2026 Chile wildfire should be understood as more than just one wildfire disaster. It was really a larger environmental case study that connects climate change, air pollution, and post-fire soil impact all in one event. These are my sources that I use for my presentations, and thank you very much.